Okay, guys, let's start talking about types of reactions. If we know the type of the reaction, then we can predict what the products will be just by knowing what the reactants are. So this is a very useful skill, and it does take a little bit of practice. So let's see what we can find out about reaction types. There are 5 types of reactions: combination or synthesis. I will call it synthesis just because that's how I learned it. Decomposition, single replacement, double replacement, and combustion. And some of these, a reaction can fit into more than one reaction type, but it will still give us some information about what type of reaction it is and what kind of products we should expect. So the first type, combination or synthesis. General equation is we have 2 substances. They could be elements or they could be compounds, and they combine to make one larger product. And so we have in the picture here magnesium ribbon that has been ignited or burning in the presence of oxygen, and it will form magnesium oxide. So if you see 2 elements, you're likely looking at a synthesis reaction. So combination or synthesis reaction is a chemical change in which 2 or more substances react to form a single new substance. So only one product, and that will tell you that it is a synthesis reaction. Decomposition is basically the reverse of a combination or synthesis reaction. We have one reactant that will break into 2 smaller pieces, and those could be compounds or elements. In this case, it's 2 elements. We have mercury 2 oxide that is decomposing into mercury liquid, which is a metal, and that's why it looks kind of shiny there, plus oxygen gas. If you have only one reactant, there's no other reaction it can be. It must be a decomposition reaction. So, third reaction type is a single replacement. And I strongly urge you to write down each of these reaction types. So if that means you need to pause now and go back and write out these reaction types, I would write the general equation. Well, first off, the name of the reaction type, the general equation, which is here right under the reaction type, and here's the general reaction, and then down here is an example. So I would write all of that down for each one. So when we have a single replacement, we have one compound and one element, and that element will replace the same type of element in the compound. So if that element is a metal, metals form cations, it will replace the cation. If it is a nonmetal, nonmetals form anions, and it will replace the anion in the compound. In this case, below we have water that is reacting with potassium metal. So the metal is going to replace the hydrogen and give us KOH and hydrogen gas. The hydrogen gas is what ignites, and that's why you see a flame there. It's also exothermic, which is what's causing it to burn. The fourth type of reaction is double replacement. Here we have 2 ionic compounds, and the cation from the first one, in this case R, will replace the cation in the second reaction, which is T, and we will form a new compound that is R with U and T with S. And again, we have to remember to get those in the correct order because we need to have the cation first and the anion second, and then the cation first and the anion second. When we do this, we often form new products, and when those new products, some of their physical properties, in this case, lead iodide, this orangey color, is insoluble, and it's going to form a solid. And so we'll know that it's reacted because we'll see a solid appear. Because if you look in the first picture, we have 2 reactants, They're both clear, colorless liquids. When we pour them together, we get something new. And so that's one of the signs that we have created a new compound. And the last type is called combustion. And this is almost always a hydrocarbon, some kind of carbon and hydrogen compound with oxygen to form carbon dioxide and water. They're going through a very complex system of trying to figure out how to balance it. I think you guys are good with just balancing it the same old way we've been balancing it. We may talk later about these if you're having trouble with it. If we have plenty of oxygen, we make carbon dioxide. If we have incomplete combustion, then we may make either carbon, which is soot, or we may make carbon monoxide, which of course we know is poisonous. And so there's our 5 reaction types. Make sure you have, like I said before, the type of reaction, the general equation, and an example of each one in your notes. So when mercury decomposes, when it's heated, it breaks down into 2 simpler substances, mercury and oxygen. Pretty straightforward. We've talked about this. Decomposition reactions involve only one reactant, so you know right away that it is decomposition if you have only one reactant. The products could be elements or compounds, and most of these require heat, light, or electricity to happen. Water doesn't just magically break down by itself. We actually have to add electricity to it. If you've ever been into an automobile accident where the airbag deploys, you have experienced firsthand a decomposition reaction, and that is sodium azide pellets decompose to give us nitrogen gas and sodium metal. And you'll notice that sodium or nitrogen gas is what inflates the airbag. It does this fairly quickly, and I recommend, ladies and gents, you sit as far from your steering wheel as you can, because the airbag deploys with quite great force and can cause abrasions on your skin. And it can also, if you have your hands in front of the airbag when it deploys, it can break your wrist. It's a very violent reaction. So I'm going to leave you here. I want you to write out these 2 products, or the products to these 2 examples. I'm telling you that A is a combination reaction, and I want you to write 2 possible reactions.